Excited today to sit down with Andrew Paulson, our automation manager and I&E manager out of the Twin Ports region. What are we usually doing on a shutdown that makes a ton of sense for a facility to be thinking of? There's been a lot of conversation, Andrew, in the industrial business space about 70E and 70B, and now we're talking about 70B used to just be a recommendation, and it's now a standard that facilities are following, or a standard of NFPA. And as a result, once something becomes a standard and no longer a recommendation, usually the next thing that happens is insurance companies start asking these folks that, let me see your NFPA 70B plan to ensure that my dollars that I'm putting out there on your facility are going to be well used. And in the 70B plan, we're seeing every single piece of electrical equipment has to be identified in a facility. And then the maintenance of that from a safety perspective has to be written, documented, and actually followed and tested. And these, again, are not things that every single electrician can do. So walk me through a little bit, when we're up in Cloquet, what kind of standard testing you're doing up there.
Yeah, there was actually several different tests going on. Cloquet takes some outage time, and when they take outage time, everything needs to be done at once, which is a little different than a lot of facilities. A lot of facilities will they like to just take down, say, a section and do these breakers during this outage. At Cloquet, we ended up doing transformers. So to start with small stuff, we do oil sample testing, pull samples from all of their oil transformers on site. The other stuff that we did with transformers is their dry type. So in the section that was deemed to be done in 2026, we had to go through and do turn ratio testing. We had to test, we had to clean the entire transformer. We had to magnet transformers, and went through to make sure everything was fine. You go through, pull all the covers off. This is really the only time that these things get inspected. We'd be pulling off tap positions. We're going to be pulling off the main leads coming in, basically putting that thing through all the tests that it would have when it left the factory years ago.
And why are you, what's the intent of it?
The intent is to find something that's starting to go wrong. You're looking for a potential failure place. If that transformer fails, there's a very good chance that it's not going to have a safety aspect at that time, but your uptime is going to go away as well. So if you lose a large transformer, you're probably going to lose a section of your plant. If you lose that section of your plant, you can't operate it, of course. And the transformer isn't one of them kind of things where, oh, we got one sitting in back. It's probably going to take 6 months to build one too. That is a considerable amount of income loss.
So a lot of these standards on the 70B are already being followed because the potential for production loss was already present. And so facilities that have been around for a long enough time have enough experience to know that, well, if I lose this transformer, I'm tubed. So we're just going to go ahead and put this on how often are they looking at them? I suppose it depends on the manufacturer.
It depends upon the manufacturer, depends upon the actual part, and it depends upon the operational environment. There's 3 different standards in 70B for different environmental conditions. So you can have real bad conditions, say, take sample in the area of a pelletizer at mine, where you've got all kinds of highly conductive dust on everything. That's going to be every 6 months. They want you looking at this stuff.
Okay.
You'll go to your next standard, and your next one would be a rough environment. So you're not, say the thing's sitting at 110 degrees every day and it's dusty, that kind of environment. That one's going to probably be every 2 years, depending upon which tests you're doing. For most standard ones, especially like what we saw down in Cloquet, they're in a controlled environment, and these transformers are actually sitting in an air-conditioned MCC room. That means they go look at the thing every 5 years.
Okay.
70B comes in, more so on the side of safety that goes along with these same tests. There is always that possibility when something fails, it's going to be bad. It could arc over. It could have a big explosion. There's all kinds of things that could take place on a transformer as well.
Okay. And so when you said you're sending in oil samples, you're sending those out to a lab and
Yeah.
they're sending you a report back.
Yep. And the oil samples will tell you what state of degradation it's in. Every transformer doesn't last forever. Everything breaks down. It's just like your car engine. Eventually, it's going to go, right?
Yeah.
So the best way and easiest way to tell that is to do some standard quality samples and a DGA test on transformers oil samples. When you do that, the lab they know their standards and they can tell inside there of what's going on in place of that transformer. If there's arcing going on inside of it, it'll show up in the oil. If there's other things for degrading, they can see copper breakdown. There's all kinds of things that they're going to be able to tell just from them oil samples sent in.
Huh.
Which is great if you have an oil-filled transformer, but if it's a dry transformer, of course, then the other tests.
Then it's a bit more of a guessing game on the dry ones.
It is. It isn't as easy to get that information. So on an oil-filled transformer, you can still do the turns ratio testing, and it should be done every 5 years as well, and other things inside of that transformer for your megging and everything can still be done. But the oil gives you just that much more information.
Yeah.
And for something that's that cost, I mean, it's not a high cost item. It's something that 70D recommends doing every year unless the lab tells you to do more.
I in Gillette, Wyoming, they have the North American Industrial Electrical Alliance, and at our annual conference last year, I attended a transformer maintenance class, and this was an hour-long class, and I had never ever heard so much about transformers. I realized it was so much that you should be thinking about from a maintenance perspective and what the ramifications for not doing it truly are. Like anyone with a facility that's counting on that facility giving them production at the end of it, whether it be a mine, a manufacturer of it, it don't matter. They better be paying attention to their transformer because that's where everything kind of starts.
Absolutely.
Without it, you're not in business. There's also other parts though along here that we go into like breaker maintenance.
Absolutely.
Talk a little bit about what we were doing there specifically and the why behind that.
We did both medium voltage breaker maintenance and low voltage breaker maintenance on this outage. Medium voltage at this site was either 2300 volts or 4160 volts. Most all of it was 4160 there. There's a couple different things that you do with that. With medium voltage, you're going to do secondary injection testing. On all of the medium voltage at this site, they have digital relays controlling it. And a couple of electromechanicals, but mostly digital relays. So what we would do is we pull out the breakers themselves after everything is fully locked out. Thankfully, the entire facility, we were able to take power on this one. So everything was ran by generators. So we had a very safe environment. We would pull out the breaker. You got to check the vacuum bottles that are on these breakers. So on a medium voltage breaker, you have a vacuum bottle inside there. So when your contacts actually close to be able to put power onto the system, you're always going to get an arc. With a free air breaker, the arc is not controlled. You're going to have a wide arc, so to say. At 4160 volts, that can be very dangerous. So what they do is they actually put it inside a vacuum bottle in this situation, and that vacuum bottle controls how big the arc is. Well, over time, those degrade as well. So one of the big tests that you have to check there is you have to check the integrity of the vacuum bottle. You do that by megging and high potting inside each one of these across the vacuum bottles. You would also meg all other connections on side of the breaker itself. You'd then put the breaker, clean everything, put it back into the housing, and then you would secondary inject current into the digital trip units. What'll eventually happen is you'll see the trips on the digital trip units, and that has to coincide with what they're programmed for. And all of that data needs to be recorded.
So first you got to get all that trip data from the facility.
Yep, either from the facility or you can power up the unit with 120 off your generator, pull that data as yourself as well. A lot of them you have to change the trip settings on because the trip units aren't our test equipment. Any test equipment out there isn't strong enough to be able to produce enough current. Secondary injection, it's not as big of a problem as primary injection. 480-volt breakers, those we primary inject. So we'll take our primary injection unit and actually put full current to those for tripping them. Same thing, you got to pull the breaker out of the unit, clean everything. You don't high pot these units because they're low voltage. High pot is an extremely high voltage rating. But you would make all connections inside of it. They're free air breakers, so you don't have vacuum valves to worry about. And then you would put primary injection, so primary current directly to the stabs. And you would do it each phase and then phase to ground on each one of these. Same with the medium voltage.
And you're just looking for it to make sure that that breaker, in essence, is tripping at the right level of current.
Exactly.
Yeah.
Yep. And you'd have to know all those settings. And once again, you'll have to derate the trips units that are on the breakers down to be able to trip with the current that we're allowed to produce with the test sets.
And is this one specific in NFPA 70B to your knowledge? Is there some pretty specific standards around
Yes. They actually have a full set of guidelines in there and a test sheet in there that we've molded all of our test sheets off of to follow all of the individual tests. It's very well broken out in 70B of every test that needs to be done per what kind of breaker it is.
Okay. And have you found breakers that have not met the standard?
Yes, we have. We've found several. On this particular job, we found 2. We were able to fix both on site just by working the breaker. What happens a lot is these things sit and they just run. So all these big 480-volt breakers, they're all feeder breakers. So these are the large ones. These are the ones where it's coming in and you turn power on and it never gets shut off because everything downstream is where they turn power off.
Yeah, if they're going to do a project somewhere, they're locking it out at the next.
Yeah, so lower source.
Yeah.
Yeah. So these guys sit there and they're not used much. A lot of times that'll actually make the mechanisms inside of them, it may want to trip, but it doesn't because it's just gummed up or something. We did find 2 of them that we had to take apart further to clean farther inside of them and re-grease some parts inside there. Once we were able to grease those, they passed all inspections and tripped where we were supposed to.
So had you not done that and there was too much current coming through there, the risk was there that potentially you could have had a
very good chance they wouldn't have tripped, at least not at the current that we wanted them to trip at. And then your breaker is basically a conductor at that point, which is very unsafe.
So I would imagine as we're doing this, and I obviously know this because I've seen it done, but there's a lot of paperwork we're filling out. There's some checks and balances to make sure that we're not just, and it's on the company or the facility owner that they have this recorded to meet this requirement of the 70B.
Yep.
Yeah. What, when you go to put these back in, then have you ran into challenges? One thing that I'm always entertained by or ponder about with maintenance items is you take something down and in that process of taking it down, examining it and then putting it back, there can be failures that happen and you can't necessarily say it's because you took it down, but you can't necessarily say that helped it either. Right. And so like even in a breaker situation, when you're pulling out a breaker, did the jostling of it, the maneuvering of it somehow cause some dust buildup to shift and now all of a sudden it's gummed up? I don't know if that's a thing or not, but we went into that.
We have ran into that. We have ran into, especially when you operate these breakers, there's a part in there that's ready to give away. It was fine as it was sitting in its state, but when it tripped, it actually breaks apart. We've seen that in the past. We've seen breakers come in from other places that we've done them. They actually don't work at all. And they have physical mechanism that say I've broken it off. The nice part about these big ones is 9 times out of 10, you can get parts and replace parts, and you don't have to replace the whole breaker because it's very costly.
Yeah. And I noticed that at one of the industrial facilities on a pipeline project when we were doing some breaker maintenance work, they had a couple that were bad, but they were just parts and they had some old ones right over here. And it was like super easy to get the thing back in and going. And boy, as much as I like to internally battle that conversation about maintenance versus just repair, like let it fail and then go repair it. I have seen in many cases where we pull those things down, we find these little issues that you're talking about, make them safe again, make them reliable, throw them back in, and then you just remove the potential for a repair and you've increased the electrical reliability of your system. And I think today, probably more so than ever, the electrical reliability on a system is just absolutely critical because with all of the construction activity and all of the work around AI centers and data centers and different industrial growth that we've had in America, getting things is not the same it once was.
No, absolutely not. It's hard to get stuff now.
And you spent how many years at the paper mill?
Was it paper mill for just under 15?
In that 15 years you were at the paper mill, compared to what you see today, has it changed dramatically from getting parts?
Yes, it has, especially electronic parts. Your standard stuff is still pretty easy to get, but sometimes electronics might be 6 months out. And when I'm talking electronics, even in these breakers and everything like that, it's the electronic part that trips it. That's usually the part that fails. And if you need to be able to get that, and you don't know it's bad, and you need it to run, that's a bad thing. It's very good, and we always recommend to all of our clients, if there's parts that are that important, you should have a spare sitting on shelf.
Yeah, you should have a storeroom, and most of these folks have been down this road that they just have that.
Absolutely.
It's not their first rodeo, but I think, yeah, it's been an interesting shift because everything is becoming more and more electronic and more automated. And with that, the maintenance of those systems becomes more critical because the replacement is not what it once was. You can't, to use old terminology, Jimmy rig it to make it work. The product isn't there. Or the component rather isn't available.
Exactly. It's very hard, and it's a good thing, but it's very hard to make something work the way it's not supposed to anymore. And the reason that it's gone so much towards that, plus the electronic component of it, is the safety factor, which brings that 70B right back around, that this thing needs to work the way it's supposed to. And that's really all we're checking for, because if it doesn't work the way it's supposed to, someone could die.
Yeah, and I think there's a lot of folks inside these facilities who are really qualified. They're really specialized. They do one piece at the facility and they do that part really, really well.
Mm-hmm.
And the whole point is in here is we want to make sure that as they're showing up to do their portion of the job, there's not some unknown risk over here that's about to consume the facility, the people in the facility, the product, whatever, some bad explosion or like to happen. So 70B has been really interesting for me to get my mind around. And at first it was like, oh, another organization came up with another way of enforcing some things.
Yeah.
But when you actually dig into it and you think globally and just over time how specialized everything has gotten, there is an increased risk of, if somebody didn't do their piece correctly, someone could just have an unknown hazard pop into their life.
Yeah.
That a breaker didn't trip because somebody, I don't know, didn't maintain it, and that maybe they didn't even install it correctly to begin with, but everything was fine all the way up until all of a sudden it wasn't.
Yep.
And the person out on the floor is paying a pretty big price for that issue.
I think it's very easy to look at equipment of it's running, it's working great.
Yeah.
Why do I need to worry about that? But 70B has made it now where we have to worry about that. And someone needed to do it, in my opinion.
Right, and it's not just your industrial facilities. NFPA 70B actually applies. OSHA has taken it as a standard, so it's everywhere in everything. So I think we're going to start seeing more and more facilities and more industrial folks kind of pause and say, hey, well, and it starts when their procurement people are going to get their annual insurance renewed. Mm-hmm. And the annual insurance person is saying, hey, what about this 70B? Let me see your 70B plan. We've had some clients who don't even, it's news to them, 70B in totality. And one of our first questions is, well, what electrical equipment do you have in your facility? And they don't know. And we've actually worked with them to generate a list of, okay, here's all of your 70B qualifiable equipment, or your electrical equipment list, and then from there try to develop a maintenance plan based around the 70B standard. And
Absolutely.
yeah, I think we'll see more of that.